R is a programming language and software environment for statistical computing and graphics supported by the R Foundation for Statistical Computing. The R language is widely used among statisticians and data miners for developing statistical software and data analysis. Polls, surveys of data miners, and studies of scholarly literature databases show that R's popularity has increased substantially in recent years. R is an implementation of the S programming language combined with lexical scoping semantics inspired by Scheme. S was created by John Chambers while at Bell Labs. There are some important differences, but much of the code written for S runs unaltered. R was created by Rossi Harker and Robert Gentleman at the University of Auckland, New Zealand, and is currently developed by the R Development Core team, of which Chambers is a member. R is named partly after the first names of the first two R authors and partly as a play on the name of S. R is a new project. The source code for the R software environment is written primarily in C, Fortran, and R. R is freely available under the GNU General Public License, and pre-compiled binary versions are provided for various operating systems. While R has a command-line interface, there are several graphical front-ends available. Statistical features. R and its libraries implement a wide variety of statistical and graphical techniques, including linear and nonlinear modeling, classical statistical tests, time series analysis, classification, clustering, and others. R is easily extensible through functions and extensions, and the R community is noted for its active contributions in terms of packages. Many of R's standard functions are written in R itself, which makes it easy for users to follow the algorithmic choices made. For computationally intensive tasks, C, C++, and Fortran code can be linked and called at runtime. Advanced users can write C, C++, Java, Net, or Python code to manipulate R objects directly. R is highly extensible through the use of user-submitted packages for specific functions or specific areas of study. Due to its S heritage, R has stronger object-oriented programming facilities than most statistical computing languages. Extending R is also eased by its lexical scoping rules. Another strength of R is static graphics, which can produce publication-quality graphs, including mathematical symbols. Dynamic and interactive graphics are available through additional packages. R has its own LaTeX-like documentation format, which is used to supply comprehensive documentation, both online in a number of formats and in hard copy. Programming features of R. R is an interpreted language. Users typically access it through a command-line interpreter. If a user types 2+2 at the R command prompt and presses Enter, the computer replies with 4, as shown below. Greater than 2+2, 1, 4. Like other similar languages such as APL and MATLAB, R supports matrix arithmetic. R's data structures include vectors, matrices, arrays, data frames and lists. R's extensible object system includes objects for regression models, time series and geospatial coordinates. The scalar data type was never a data structure of R. Instead, a scalar is represented as a vector with length 1. R supports procedural programming with functions and, for some functions, object-oriented programming with generic functions. A generic function acts differently depending on the type of arguments passed to it. In other words, the generic function dispatches the function specific to that type of object. For example, R has a generic print function that can print almost every type of object in R with a simple print syntax. Although used mainly by statisticians and other practitioners requiring an environment for statistical computation and software development, R can also operate as a general matrix calculation toolbox, with performance benchmarks comparable to GNU Octave or MATLAB. Arrays are stored in column major order packages. The capabilities of R are extended through user-created packages, which allow specialized statistical techniques, graphical devices, import, export capabilities, reporting tools, etc. These packages are developed primarily in R, and sometimes in Java, C, C++, and Fortran. A core set of packages is included with the installation of R, with more than 7,000 additional packages available at the comprehensive R archive network, Bioconductor, Omega Hat, GitHub, and other repositories. The Task Views page on the CRAN website lists a wide range of tasks to which R has been applied and for which packages are available. R has also been identified by the FDA as suitable for interpreting data from clinical research. Other R package resources include CRANtastic, a community site for rating and reviewing all CRAN packages, and RForge, a central platform for the collaborative development of R packages, R-related software, and projects. RForge also hosts many unpublished beta packages, and development versions of CRAN packages. The Bioconductor project provides R packages for the analysis of genomic data, such as Affymetrix and cDNA microarray object-oriented data handling and analysis tools, and has started to provide tools for analysis of data from next-generation high-throughput sequencing methods. Milestones. The full list of changes is maintained in the R News file at CRAN. Some highlights are listed below for several major releases. Interfaces. Graphical user interfaces architect cross-platform open-source guide for data science based on Eclipse and Statet. DataJoy, online R editor focused on beginners to data science and collaboration. Deducer, GUI for menu-driven data analysis. Java GUI for R, cross-platform standalone R terminal and editor based on Java. Number Analytics, GUI for R-based business analytics working on the cloud. Rattle GUI, cross-platform GUI based on RGTK2 and specifically designed for data mining. R Commander, cross-platform menu-driven GUI based on TCLTK. Revolution R productivity environment. Revolution Analytics provided Visual Studio-based IDE, and has plans for web-based point-and-click interface. RGUI comes with the pre-compiled version of R for Microsoft Windows. RK-Ward, extensible GUI and IDE for R. RStudio, cross-platform open-source IDE. A special issue of the Journal of Statistical Software discusses GUIs for R, editors and IDEs, text editors and integrated development environments with some support for R include Context, Eclipse, Emacs, LYX, Vim, Gedit, Kate, Revolution R Enterprise developed, RStudio, Sublime Text, TextMate, Atom, Winnet, TinR, Notepad++, and Architect. Scripting languages. R functionality has been made accessible from several scripting languages such as Python, Perl, Ruby, Fhash and Julia. Scripting in R itself is possible via a front-end called littler. User conferences. The official annual gathering of R users is called User. The first such event was User 2004 in May 2004, Vienna, Austria. After skipping 2005, the User Conference has been held annually, usually alternating between locations in Europe and North America. Subsequent conferences have included User 2006 Vienna, Austria, User 2007 Ames, Iowa, USA, User 2008 Dortmund, Germany, User 2009 Rennes, France, User 2010 Gaithersburg, Maryland, USA, User 2011 Coventry, United Kingdom, User 2012 Nashville, Tennessee, USA, User 2013 Albacete, Spain, User 2014 Los Angeles, USA, User 2015 Aalborg, Denmark, User 2016 Stanford, California, USA. Comparison with Shash, SPSS, and Stata. The general consensus is that R compares well with other popular statistical packages, such as Shash, SPSS, and Stata. In January 2009, The New York Times ran an article about R gaining acceptance among data analysts and presenting a potential threat for the market share occupied by commercial statistical packages, such as #. Commercial support for R. In 2007, Revolution Analytics was founded to provide commercial support for Revolution R, its distribution of R, which also includes components developed by the company. Major additional components include Parallel, the R productivity environment TIDE, RevoScaler, RevoDeploy, Web Services Framework, and the ability for reading and writing data in the ## file format. In 2015, Microsoft Corporation completed the acquisition of Revolution Analytics. For organizations in highly regulated sectors requiring a validated version of R, Mango Solutions has developed the ValiD-R product, which fully complies with the Food and Drug Administration guidelines for software verification and validation. In October 2011, Oracle announced the Big Data Appliance, which integrates R, Apache Hadoop, Oracle Linux, and a NoSQL database with the Exadata hardware. Oracle R Enterprise is now one of two components of the Oracle Advanced Analytics option. IBM offers support for in-Hadoop execution of R, and provides a programming model for massively parallel and database analytics in R. Other major commercial software systems supporting connections to or integration with R include JMP, Mathematica, MATLAB, Spotfire, SPSS, STATISTICA, Platform Symphony, #, Tableau, and Dundas. TIBCO offers a runtime version R as a part of Spotfire. Examples. Basic syntax. The following examples illustrate the basic syntax of the language and use of the command line interface. In R, the widely preferred assignment operator is an arrow made from two characters less than, although equals can be used instead. Greater than x less than c # create ordered collection greater than y less than x squared # square the elements of x greater than print # print y 1 1 4 9 1 6 2 5 3 6 greater than mean # calculate average of y. Result is scalar 1 15.16667 greater than var # calculate sample variance 1 178.9667 greater than lm_1 less than lm # fit a linear regression model y equals f or y equals bo plus #. Store the results as lm_1 greater than print # print the model from the lm_1 call. LM coefficients by -9.3337.000 greater than summary # compute and print statistics for the fit # of the lm_1 call. LM residuals 1 2 3 4 5 6 3.3333 -0.6667 -2.6667 -2.6667 -0.6667 3.3333 coefficients. Estimate STD. Error t-value PR -9.333332.8441 -3.282 0.0304553 * by 7.0000 0.7303 0.000662 * Signif. Codes 0 ****, 0.001 0.01 0.05 0.1 residual standard error 3.055 on 4 degrees of freedom multiple R squared 0.9583 adjusted R squared 0.9478 F statistic 91.88 on 1 and 4 df p-value 0.000662 greater than par, hash request 2 by 2 plot layout greater than plot, hash diagnostic plot of regression model structure of a function. The ease of function creation by the user is one of the strengths of using R. Objects remain local to the function, which can be returned as any data type. Below is an example of the structure of a function. Function name less than function, hash declare name of function and function arguments statements, hash declare statements return, hash declare objects data type. Sumo f squares less than function, hash a user created function return, hash return the sum of squares of the elements of vector x, greater than sumo f squares 1, 14. Mandelbrot set short R code calculating Mandelbrot set through the first 20 iterations of equation z equals z2 plus c plotted for different complex constants. C. This example demonstrates use of community-developed external libraries, in this case CATools package, handling of complex numbers, multi-dimensional arrays of numbers used as basic data type, C variables c, z and x. Install.packages hash install external package library hash external package providing write.gif function jet.colors less than color palette m less than 1000 hash. Define size C less than complex. Each equals M, imag equals wahida, M, C less than matrix hash reshape as square matrix of complex numbers Z less than 0 hash initialize Z to 0 X less than array, hash initialize output 3D array for, hash loop. With 20 iterations Z less than Z squared plus C hash the central difference equation X, K, less than EXP, hash capture results, write.gif bibliography.